Hello and welcome to Web Math Academy. Today we're going to look at our third and final module on the use of limits, and in particular today we're going to look at a situation where a limit does not exist for a particular function at a particular point. First we look once again at one-sided limits. Consider the following function. f of x equals 2x for x is greater than 2, or x plus 2 for x is less than or equal to 2. We want to find the limit at x equals 2. If we compute the limit of x plus 2 at the value of 2 from the left, we get 4. And if we compute the limit of 2x as we approach 2 from the right, we also get 4. Since the right and the left limits at 2 are the same, the limit exists and is continuous. We can see this displayed on our TI-Nspire calculator. Now, if we alter the function slightly so that it still remains 2x for x is greater than 2, but x for x is less than or equal to, and we compute the following left and right hand limits at x equals 2. Approaching 2 from the left, the limit of x equals 2. Approaching 2 from the right, the limit of 2x is 4. So we can see here that the left and the right hand limits differ. The limit is discontinuous and does not exist. We can see this also if we plot both functions on our TI-Nspire calculator. You can see they do not connect, and therefore there is no limit at x equals 2. Now, on to limits that deal with infinity. There's two cases to look at. The first one, consider the limit of 1 over x as x goes to infinity. Now we can make a table of values as follows to determine this limit. Here we see that as we increase x from 10,000 100,000, that the value of 1 over x gets increasingly small. In fact, as x gets larger and larger towards infinity, x gets smaller and smaller towards 0. So in fact, this limit exists and is simply the limit as x goes to infinity of 1 over x equals 0. Conversely, let's determine the limit of 1 over x to the fourth for x going to 0. We can make another table of values, and here we see that as x is made smaller and smaller and smaller, the function 1 over x to the fourth becomes bigger and bigger and bigger. In fact, we can see that as x approaches 0, f of x becomes quickly large on its way towards infinity, and as such, this limit does not exist. If you compute the limit using your TI-Nspire calculator, you will get the answer of infinity. And if you were to graph that, you would see here that as x gets vanishingly small, f of x goes all the way up towards infinity. That's all we have on the discussion of limits. If you have any questions or comments, you can leave them at our website, webmathacademy.com. Thank you.